please. All right, hi everyone. This is a Wolfram Language Design review about spatial statistics. So we already had a bunch of spatial statistics in 12.3, right? Or was it in 12.2?
I think 2.
Okay.
If you want to, I can give sort of a bit run up to what this is, this part.
Okay.
The previous spatial statistics, its main objective was basically spatial events, like trees, the distance and density of those kinds of things, and models for how
we're talking biological trees here.
Yeah, and stars and particles, things like that stuff. This time around, the main objective is basically continuous functions of as function of spatial locations. So think of elevation, for instance. Or think of ozone levels, or think of mineral deposit layers, or things like that.
Okay.
Where you have partial measurements and you would like to fill in the missing data, if you like.
So like spatial interpolation of some kind.
Yes, exactly. And the model, and so we have elected to not do the basic, a comprehensive model where we have models for this. For models for this would be things like stochastic partial differential equations and things like that. We've not done that, but we've done the killer use case, which we think is to take data and fill in the missing values with interpolation, or it's really an approximation.
Why aren't we calling it spatial interpolate? I mean, predict is a brand that we've used for
the problem is that it isn't interpolation. It's not interpolation.
You mean it doesn't hit the data points?
Right. It's not interpolation. And I don't think we should use interpolate for things that doesn't interpolate.
But just to be clear, what we mean by that, by interpolate, you mean hit the data points that are given.
Yeah.
The question is, does this hit the data points that are given or not?
It does not. Okay.
So it's making a function that attempts to be a spatial approximation of some kind, but it isn't, it's not. So
it's not an interpolation.
I understand. It's kind of like a fitted function, except a fitted function generally, well, a fitted function doesn't necessarily hit the points.
Yes, exactly.
But the problem is that predict...
They're all examples of approximation. So is predict is an example.
I know, but a predict is a very specific machine learning thing.
Okay.
In our system.
Okay.
I really don't like using it here. I mean, I think that it's...
Well, fine.
Don't we have a time series predict as well?
Yeah, that's also a predict. I mean, actually, it's called forecast.
Okay, but that's different. Okay, which is good because it doesn't use the predict brand.
Right.
Okay, sorry. So wait a minute. The geodensity plot, we have geodensity plot, don't we?
Yeah.
Or do we? Yeah.
But we really want to use this function for that. Underneath that, it goes through contortions to use what we have. So.
Okay. So we should look at this page.
And most likely we'll start flowing in for a lot of our list plotting functions to use this kind of function.
Okay, this is not working. Something is set up wrong here. Can you just send me this file, please?
This is spatial predict, not prediction. Predict.
Oh, spatial predict. The guide page.
Oh, the guide page is okay. There's a guide page, spatial prediction. Okay.
Yeah, go to the guide. It has links to everything. If you click on that other thing, it's actually going to work because this Apple search thing doesn't work so good.
Which other thing is going to work?
Click on that QR or 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 whatever it's called. The open guide page button. You're going to love it.
Okay.
Get used to using it and you'll love it.
Okay. All right. So the basic point here is this is going to be like an interpolating function. You're going to give it, is it list pairs? Is it list XY? for the coordinate positions?
It's location values.
No. What I'm asking is, when I have this function and I use the function, right? I'm simply
when
asking,
you're using the function, it takes the list. The list.
Oh, yes, right. I mean, spatial predict here of, I don't even understand what any of this is. So this spatial predict, if I feed it, a particular lat long, for example.
You get a value.
Okay, but now how does it know it's, I see, the function originally decides it's going to eat lat longs. Is that right?
Yes.
As opposed to eat, for example, pure numerical coordinates.
Yeah, it can do both.
Okay, fine.
And it does like transformation function. If you have a list of points, it will compute, listability across that, set of points, that list of points.
So what's the analog of this in time series?
What do you mean of what?
Well, what's the analog of what this is doing in a time series? So in other words, in a time series, I may have specific data points and I want to interpolate the time series. How do I do it?
I mean, the time series literally interpolates on its own. I mean, it just does that. That's what time series does. That's the definition of time series. And it literally uses interpolation. Okay,
so why is what we're doing here? So what we want to do here, for some reason,
so interpolate doesn't work particularly well. So first of all, interpolation doesn't work particularly well when you have sparse data that you often have in the geo situation.
Okay, so for time series, you're saying it does work because you know nothing, you don't have some background geometry.
No,
that gives you.
There is a value. There's a whole set of models called time series models,
right?
That are similar to these, and time series forecast makes use of those.
Okay, but so what I'm saying is, design-wise, we're not being consistent here. That is, ARMA models or whatever else it is, all these back-end models. Right? One could imagine something where you take the sparse time series data, right? And just like you're saying spatial predict here, you could say something like, time series predict, and you'd get a time series predictor function or something, or a temporal predictor function, and it would all work the same.
Yes, one could imagine that.
So let's think that through for a second. I mean,
so maybe one question would be, if this basically also encompasses the stuff we were talking about with GeoRaster, right? Because then you could imagine having some object, like you have a time series object that's, that's sort of a queryable interpolating thing. But I guess maybe a question would be, if you had some like remotely sensed data or something like that, where you've got like millions of points, it's like 5 gigabytes of raster data. Is it at all practical to represent it like this, and have interpolation and stuff like that, or is it just going to be super slow?
Roger, were you in the GeoRaster conversation?
No.
Okay, so you guys need to know about that. So you understand what the point is. The point is, you've got an image that has been sampled with a particular projection of the Earth because it's based on some satellite that's looking at the Earth in some particular way. But that it's a slant. The satellite is at a slant angle, for example, right? But then the question is, what is the actual density of whatever they are on the surface? What's the actual area that has this temperature on the surface of the Earth or something? Do you get what I'm saying?
Yeah. So I assume that it means that you have geo coordinates that describes what you sample. Is that the issue?
I think it was basically just georeferenced images. Yeah.
I got it. Okay.
But I guess the question is, is this basically just a better way of representing georeferenced images where, each pixel turns into a point and you have interpolation and stuff like that? Or will this just get destroyed when you put that much data into it?
Well, this can be made. It is fairly efficient. I don't know that we have sort of sent it like gigabytes of stuff, but it can be made more efficient if that's, I don't think it's been designed for what you described, like gigabytes.
But it seems like we have to get design consistency between the GeoRaster functionality and this.
Well, I don't know what GeoRaster
I know.
is.
So, okay. So where do we have, Somebody
I mean,
said-
isn't it the main thing for GeoRaster to have the meta information that says where the hell it is?
No, it's also this transformation stuff.
I mean, I think the point is you just want to be able to, you want to be able to do things like, okay, you have 2 GeoRasters that maybe have.
That sounds like just a data container that needs to know where it is.
No, no, Roger. It needs to know its
so why is it called
projections,
raster
like
then?
Well, no, where it is includes the projection, presumably, right? I mean, I think it is just a geo-referenced image, but there's a bunch of stuff about you want to be able to do operations on them and combine them and so on. But the question is whether or not that functionality can basically just be encompassed by this stuff here.
I think not, but I think they have to dovetail together.
Yeah.
So I mean,
can one interpret a raster as a bunch of points? I guess one could.
One could. It's just complicated, and it's not. I mean, it's like saying an image. We've got this concept of image data, which takes the image and turns it into an array.
Mm-hmm.
And but the fact is, there's a huge amount of operation, stuff one does to images as images, and occasionally, in rare cases when one wants to do an operation where it doesn't work just with images, you get the image data and do the operation on the array. And I think the same will be true here.
Yeah.
So I mean, that may be the API between those things may simply be that you can get from GeoRaster. There's got to be a way to get out of GeoRaster the point list that would be the same thing as spatial point data, right?
I mean, there is a thing that one can make this fundamentally pretty damn efficient. For instance, when you predict the value, you don't use values that are very far away. You limit the region, over which
I get it.
The spatial dependence relies on.
So it's basically some kind of cellular automaton or convolution like thing.
If you build spatial data structure that you only look at those points, those are the only things that they're going to depend on in a linear fashion.
Right. But so to me, one of the things which we hadn't thought of in talking about GeoRaster is being able to turn GeoRaster into spatial point data, possibly just by feed spatial point data a GeoRaster and it turns it into that, and vice versa.
Mm-hmm.
Does that make sense?
Maybe.
Who is taking notes here?
That would be me. And I'll follow up on all this.
Okay.
I mean, if you just have a bunch of points and you feed it to image, what the hell is it going to do? They might be too sparse. You might not have yourself, so it may not make sense.
You're saying feeding spatial point data to GeoRaster, it might not be, you might be right. Right.
Yeah, although also I know when we talked about GeoRaster before, we did talk about having, because when you have, a GeoRaster and you reproject it, in the new projection, it might not be rectangular. So we were talking about how there has to be some sort of alpha channel, where we're not, the whole image doesn't have to have data in it. So maybe there would be a way of doing it, but yeah.
Right, but I think it's not particularly natural if there's just a bunch of points, floating in the ocean.
Sure.
All right, let's look at the design of this thing itself. Okay.
I think that you tend to generate rasters when you have like a satellite that scans systematically over an area. I mean, often when you have drones, you're not necessarily doing that. You can follow all kinds of patterns, and it might not be as dense of a coverage.
Well, you're saying there's a combination thing, which is a pathed GeoRaster, so to speak, where there's a swath of data from a drone, for example.
Actually, interestingly, the reading that you have here is I think satellite data, but it has these missing gaps. Can you see that?
Yeah, right.
Okay. Most satellites, when they go over, they make these sorts of gaps, and there's even more pathological cases. Like I know there's this like Jedi project. I think.
Right. This is what's being filled in here with this spatial prediction function.
Okay, so this is in fact a GeoRaster type operation.
Sort of, yeah. I mean, the data wasn't presented as a GeoRaster, but
right, but it could have been. I mean, that picture there looks quintessential GeoRastery.
Right.
Okay, so we clearly do have to merge these two concepts.
Who's working on GeoRaster? I mean, where did that come from?
The Jose team, the Geo team.
Okay.
Is working on Geo and I guess Brett also. Is that right, Christopher? Do you remember?
Not really. I mean, I was sort of interested in this, and I wrote some things and I sent them to Jose, and there were some meetings about it, but I don't really know what's happened.
Right. Well, it was supposed to be an active project.
So I haven't heard of it as an active project.
I'm sorry?
I haven't heard of it as an active project.
Yeah, well, I don't think you would have done because nobody made this connection.
No, but Jose reports to me. I should know.
Well, fair enough.
Yeah, I mean, I'm not sure it's really being worked on. I mean,
should
also,
know about
just to
active
note,
projects.
I mean, the design I sent was also like has problems in it, like so it's not.
No, but we had a
there's
meeting where
lot
we
of-
actually made progress on the design, and I thought we had a plan to do this.
I mean, I think we spent. I don't think we resolved like enough that it could be like imminently implemented.
Can somebody
or
see if
something.
Jose could be found? We can just ask him. No, nobody can do that. Okay, I'll do it. Okay, so let's take a look here at what this does, although it's clearly that the design is going to have to be merged with this other idea.
So we probably won't make it for 13 then.
Probably not. Pity we didn't review this earlier. I mean, if we're lucky, this will be simple to merge. Okay, so this thing here is what? This is the spatial point process generates.
There's no processes.
I know. What spatial point process generates is some spatial point data, which this should be able to eat, correct? And this is simply a smaller, an elided version of the spatial point data, correct?
No, there's no continuous value of tree locations above any point in space. There's no continuous. You misunderstood. I mean, they're different things. Events are not the same as a continuous, surface.
Okay, what is this?
Yeah, I think spatial point data represents just a set of points. This has values associated with points.
Yes,
is that right?
exactly.
Okay, fine. What is the analog of? Okay, what's the analog? So it's a function on the point. Spatial point process is just the points themselves.
Yes.
Okay, what's the analog for spatial point data of something which has values at the points?
The value that are at points are called annotations in that case, and they are things like, tree species. We don't really model that particularly.
Okay, so wait a minute. So what we've got here, for example, in a time series, we could imagine having categorical data, although I don't think we deal with that well right now, right? But so what you're saying is that, just like a function of a graph right now, we do in this kind of slightly cruddy way of having annotations at the vertices. Right?
No, it's not cruddy. Graphs or networks are more general things than just the mathematical graphs. They represent other objects, and that's what annotations are for. You can have annotations on nodes and edges, vertices and edges.
But fine. But the point here is
cruddy. It's like the way to do it.
All right, fair enough. Okay, but although the support, the question of what support, a function on a graph.
What do you mean by a function on a graph? What the hell do you mean? I don't know what you mean.
Well, okay, you're right. It could be nodes. It could be edges.
I don't know what you mean by a function on a graph. What does it?
Okay,
what do you mean?
For example, if you compute, let's say you have my
graph has a very special meaning. It's I don't know. It's a block diagram. So what's a function on a block diagram?
Okay, look. The issue is there's some base space. There's some values. And you're right that there are different ways to define the base space associated with a graph. In the case that you're looking at here, the base space is a little bit more straightforward. It's a bunch of points in, d-dimensional space, basically.
Yeah, or geospatial space, geospace.
Mm-hmm. Okay, but so my question is, in the analog of, with spatial point data, you're saying that, like on a graph, the way you associate values with, which might be categorical or might be continuous, values or numerical values with points is through annotations. Is that correct?
Yes, it is.
Okay. So it's a slightly, that's slightly weird because in time series, for example, it is not the case. You could do an analogous thing. You could take the time of the data objects and put annotations on them. But instead, in time series, we actually have the idea that there's a mapping from time to value.
Yeah, it's like a function of time.
I know that.
This is like a function of space, but a continuous function.
I got it.
And there's no discreteness in it. There's
I got it.
Just to make that absolutely clear.
I got it. But
No
what
confusion.
I'm saying is there's two different representations that we are using for this.
No,
one
we
is
still allow for time value.
Wait a second. I'm saying in the case of time series, one thing I could imagine doing is, right now we have something which maps time value, time point to value at that point, right?
That's correct.
Okay, so now what we could also imagine doing syntactically is saying there's an annotation for that time point that stores the value, which is what you say you're doing in spatial point data.
But that's discrete. That's the different things.
No,
this discrete collection of points, of events.
I understand, but you're using that. The whole point is Spatial Predict is attempting to create a continuous function from those discrete values. Just like time series, when you actually construct it, does not start from a continuous function. It starts from a bunch of discrete values, which are then interpolated.
That's all fine. That's all fine. But the model that you should think in terms of is something continuous.
It doesn't matter. I'm saying, I'm just talking about how you enter the data. I'm saying one way to enter
but then you conflate. The next minute, you conflate two things, and then we're in a big mess. And now we don't know what we're talking about.
Which things you think you're conflating?
Can I explain?
You're conflating events and continuous things. Like an earthquake is not this. There's like not.
I know event series and time series are different. I got it.
Right.
Yes,
May
I
I?
understand.
So
Go ahead.
the spatial point data was designed as a somewhat general container, and it has the possibility to add annotations, because in the discrete, for example, cases, we talk about the tree species, you would like to annotate what species is growing at which location, but also, it might be extended to store some values which may come from continuous field, but we make no assumptions on what the values are, so what the annotations are, and that's how it differs from the time series event series.
I got it.
So we don't have per se a container that would correspond to the time series in a spatial case.
I got
at this point. So what we do, we just have the locations and values.
I got
and it may happen that we're gonna use some storage, the spatial point data in to store this type of data, but it's not automatically understood as a continuous.
I think I understood this. Okay.
Okay.
So
yeah.
just to be clear, for example, you've got trees, they've got heights, right? Is there a height field for the trees? Well, you might want to think of there being, or you might not want to think of there being.
Yeah.
Right?
There are two types of, okay, so in that field, I'm sorry, in that, I shouldn't use the name field, in that domain, okay, there are two types of annotations, okay, and they're not called annotations, it's something that we've invented. There are things that things depend on, and they're usually called covariates. So for instance, the elevation is something that depends on how frequently tree grows. Like at very high elevations, there isn't many trees growing. Okay, so that's something that you can use then to model, or that sort of depends on that. Now the output side, that's like the input side for that stuff. The output side might be exactly what we talked about, like the species, which is sort of something discrete, or its height, or actually, when you start reading these books, diameter at breast height seem to be like the killer annotation to store.
Okay.
Because people want to do, it's all started with taxation. And so resource estimates for taxation purposes of forests.
Okay. Who's taxing forests?
Well,
Don't tell me
the Germans were pioneers and the Swedes were pioneers. But I think everybody
forests.
I think everybody taxes. I bet the UK taxes forests.
Okay, maybe that was, the whole Robin Hood thing was all about taxation of trees. Who knows?
Well, you need to estimate the resources there.
Okay, in any case.
So you need to count them.
So is the basic question here just whether or not you have a function where you give it the locations and values and you get out the interpolated, value, or whether you have a container where you put in all this stuff and then it sits there and then you query it later.
Yeah.
That basically
if we had built the models, we would have simulated and generated data, in which case we would have a strong interest in building a container. That container would have itself been probably useful because it could support a bunch of spatial query-like operations and be very efficient for that. But we haven't built it because we don't need it right now.
Okay, hold on. So Jose is now here, and
Yes.
Jose probably doesn't know why he's here, but this is a collision with GeoRaster. Okay, can you remind us or point us to design documents about GeoRaster?
The only design document we had is the notebook that Christopher sent. And
But then we talked about it further, right?
Yes, but based on that notebook. So we didn't, it's a discussion we started, but we couldn't conclude in a meeting we had. So it's still pending.
Okay.
Continue.
But so the basic concept was, this is a block of values that have been, that have a particular that have a mapping to the geo base space, so to speak. Is that correct? Is that the basic concept in the end?
Yes, the original idea was to have that for images, and then we started discussing to extend it to other data, like quantity arrays of elevations or other
Right.
properties.
Okay. So that's where we intersect with this. Right. So the difference, I think, is the following: a quantity array or an image is, necessarily rectangularized data in some sense, in some coordinate system. Whereas what you're doing here is every tree for itself, so to speak.
No, this isn't trees again.
I'm just joking. You understand? Every point for itself, right? Do you understand what I'm saying? The point can be any way you want.
Right.
Whereas
and the point can be an elevation. I mean, the value can be an.
I know. The point that I'm making is, and we got too many points running around here, but okay. I'm using trees to concretify this, and I mean like conifers, those kinds of trees,
Right. But that was a bad example.
Okay, all right, fine. But what I'm saying is that imagine a tree field in which the trees are all arranged in a coordinate grid.
No, you're still confused. Okay.
Right. So
I'm not confused, Roger.
Yes,
I'm
you
not
are
confused.
I'm sorry, Stephen. You are confused. What would be related to trees that is relevant in this case and in the raster case would be something like tree density. That is a continuous field.
I got it. I'm not. It was a bad example. Okay,
it is a bad example.
All right. Okay. All right. Let's say, the intensity of color in some satellite image or something like this. But the point about it is, what I'm saying is, one thing is there is an array. And you've got a bunch of values in the array, okay? Now, you could disembody a single pixel, and you could say, I'm just going to talk about that pixel with its center location and the value of that pixel as a disembodied pixel floating around, right? Without it being embedded in this essentially coordinate grid array.
Yeah, except that there are two models of how images work. One is that this is sort of basically like a piecewise constant value over the pixel square.
Yeah.
The other one is that you associate value with corners.
Fair enough.
Okay.
I understand that there are going to be different ways to do it. I'm just trying to understand the design correspondence between this essentially point data that you have here and this notion of array data that we've been talking about for GeoRaster.
Sure.
Okay, so I
So
think
maybe these two issues sort of collide in a virtuous way, right? Because basically, okay, so maybe this function spatial predict, it can take the things it currently takes, or takes, location value rules, and then maybe if we decide later to create this container for location value rules, it could also take that, and then it could also take a GeoRaster if those exist, right? So that basically, this function is just right. I mean, so it's fine that we might have two different ways of representing, GeoRaster data versus these, value point pairs.
I'm beginning to agree with you. I mean, I'm beginning to agree, and I think that the difference is the field versus the trees, as opposed to the forest versus the trees. If you,
God,
okay,
I'm so confused.
What?
I mean, Christopher's right. Okay. But you're still confused.
I'm not confused. I'm just using bad analogies.
I think that the trees are only relevant for the spatial point, spatial point data. It's not relevant for either GeoRaster or this. Both of these assume it's a continuous function.
Yes, I understand. I agree. That's what I'm saying. You're never mind. Yes, I think I understand. Right. One of them is a continuous function sampled on a grid, and the other is something where the sample values are at random points.
Yes.
Okay, where the continuous function, there is a function in the background, but we just know its values on a grid.
Not necessarily on a grid. So that's also where this was taking into account.
I know
that you may have irregular sampling.
No, obviously.
No.
The GeoRaster case is the grid case.
Right. But
that's what I'm saying.
Yeah. Yes.
Your case is you can have points wherever you choose.
Correct.
In particular, they can be on a grid.
In particular,
for example, yes, but in that case, there will be overlap between what you can do with this sort of and what we can do with GeoRaster, except there will be a difference because, as you say, like the pixel values, it could be the center of the pixel, it could be the corners of the pixel, it could be a bunch of other things. In this case, it's like there is a point at these coordinate positions and it has this value. In the other case, it's representing a discretization of a continuous field where it goes from cell to cell, so to speak.
I think the key question here is whether there is a value that can be assigned to any point. How do you get to that value? Doesn't matter.
Well, it's like time series versus event series.
Exactly. Yes. Yeah.
Okay. All right. Okay. I think we actually converged on something reasonable here. Okay. So I see various comments in our live stream here. Sandra is commenting in fluid dynamics, the data location is random and changing over time. Yeah, well, that's a different issue, is the merging of time series and spatial
data. So this doesn't do, so ultimately, and we're just getting to this now called video, when you want to look at spatio-temporal things.
Yes.
But this one doesn't do spatial-temporal, but yes, that would be the extension. Everything can change over time and over space.
What's the difference between 3 dimensions and, what's the difference between a 3-dimensional thing like this? Oh, I see, because the difference is that things have their world line, so to speak, that a point typically will just evolve over time, whereas a 3-dimensional data set will have different random points in the Z direction, so to speak, as opposed to continuity in the T direction. Does that make sense?
Big thing in statistics and generally with time is that in particular in statistics, you would like it to be causal in time. Yeah. Meaning it only depends on its history. It doesn't depend on its future. So if you want to predict something, you don't want to necessarily.
I understand, but I think there's a different point, which is the one I was making, which is that the chances are, there is, in the case of 3D, right, you might very well have a situation where there are a bunch of random, buoys on an ocean floating around, and their position is, they're like a spatial point data in terms of position, but then as a function of time, those things don't spontaneously disappear and spontaneously appear, so to speak. So there's a different kind of continuity there.
This thing, Spatial Predict works fine in 1D, 2D, 3D, and
I understand, but it's not dealing with the thing I just said. Namely,
it's not dealing with evolution in time. No.
No, it's not dealing with the fact that there's, as far as it's concerned, every time slice is a completely new story. It's not dealing with the idea that some point should evolve through time.
Elevation sort of changes over time. Most of the time, we have like we think of it as static, not evolving over time so much.
Sure, I understand. Yeah, right. Unless it's over geological times, which is a different story.
Right.
Sandra is asking about large data and out-of-core operations, different meeting. It's a thing actively being talked about, but it's a different discussion. Yeah. Okay, Sandra comments, in experimental fluid flow fields, one often has holes or corners cut off because there's a boundary or no laser coverage. So that's very similar, presumably, to the GeoRaster case, where the satellite could have, had, I don't know what happens to satellites that cause them to have only a certain region covered. There's comments about kriging, which is the underlying method being used.
This is kriging. Okay, so this is South African mining engineer Kriege.
Ah, okay.
Okay, and so the terminology originally, that he was interested in gold mining. So the terminology for that variance, the measurement variance, it was called a nugget. We decided to not introduce the nugget terminology. But
wait. Nugget was what? Because they were doing gold mining? What?
Yes.
Okay. Parmenides on our live stream comments that slash and burn agriculture was the main way Swedes and Germans used to do agriculture. They used the ash from the trees as potash fertilizer, so forests were just farmland. Okay.
Who says that?
Person on a live stream. Don't know. You
yes.
It historically.
No, they were doing a lot of burning. Yes, but they were actually sort of exporting the trees to countries like the UK, who'd
already cut down their trees 1,000 years earlier.
Well, they cut them down pretty early. So yeah, and so they would make coke and other things and export it to Britain.
Okay. Ethan is commenting, should more like spatial interpolate. We discussed that. It can't be interpolate as such, but I don't think predict is the right word either. Let's see. Okay, so let's come back to this design. Okay, so what it's eating is these things which might one day be what would happen if you fed spatial point data a location value pair like this? Would it convert it into some kind of annotation thing or not?
It doesn't eat spatial point data just because we don't know if the annotations, are continuous or discrete.
I think he asked the other way around. What if you fed that input to spatial point data?
Right. Why can't it construct annotations from that input?
It can from the second one.
Why not from the first one?
For convenience, I would say, and the fact that we would like to have the regularity in that way in creation, so that the length of the annotations is the same. So the thing is that we're looking at the annotations, what's the word for this, as the whole set. So all configuration has annotations and not the single point. So I'd say that you can have 3 annotations on one point and 4 annotations on the other point. We do not allow that. So
I don't understand. This is not that. This is saying location value. So why isn't it the case that you can turn that into a spatial point data with a particular value annotation at every point?
In theoretically, yes. Maybe not in exactly the same syntax, but in the idea, yes.
I know, but that's my point. My point is, if you feed, I'm trying to make syntax compatibility between these various functions,
yes.
Right?
Yes.
So, you've got data in the form of location value, and now you want to do spatial statistics of the kind that we do with spatial point data on that data. Yes. I'm just saying it should not only work in whatever spatial predict gets called, but it should also work through spatial, in whatever space. Does it make sense?
Yes.
Okay. All right. Fine. Mm-hmm. Okay. Then conversely, it's less obvious if you feed spatial point data to spatial predict. It doesn't know which of the annotations is supposed to be the value, so to speak.
And that's why we don't automatically work.
I know. So let's think about
Mm-hmm.
that for a second, because how would you process spatial point data so that it can be fed to a thing that is basically looking for a spatial field? That's my question. So given spatial point data, which has where there's 4 values associated with every point in the spatial point data, now I want to say, I want to do, I mean, it's not obvious to me that I shouldn't just, that spatial predict shouldn't interpolate effectively all of them, Craig all of them. Why doesn't it do that? Some of them might be categorical.
Right.
But if it isn't categorical, why doesn't it, just as a courtesy, why doesn't it just do it? And return to you, I mean, what it's going to return is this thing, which is no longer, what is this thing? It's a spatial prediction function, right?
Predictor function, yes.
Predictor function, okay. So, so my point is, you either got to be able to slice off, okay, I don't know whether it's useful to take spatial point data and Craig all of the variables, or all of the annotation values, or whether you want to slice off a particular annotation value and then make that into a field like this.
So maybe, okay, a question about Craiging all of them though. I mean, can the values here be multidimensional, or do they just have to be a single value in spatial predict?
This is for the scalar field. So
Scalars,
if you give the vector, it's gonna be treated as an independent input.
Okay, so if there was some mechanism for quote unquote Craiging all of the variables, I mean, that would correspond to multiple calls to spatial predict, basically.
Yes.
Right now.
Yes.
Okay.
Yes.
So Ethan is asking, can this handle imputing wind vector data across the globe? A reasonable question.
Yes.
So, but you just said it was scalars, Gosha.
Well, yes, but if you treat every component on a vector individually, then you can create component wise.
But
that's 3 calls to spatial predict, right?
Yeah.
Yeah.
But so how would you represent that? So if you've got the wind data, how do we represent the wind data right now? If you say, what do we call it actually?
It's the wind data, and you can query speed, for example. So you could do the field of the wind speed.
Okay.
Hold on. I mean, there are 2 things. I mean, the first thing is that there's GeoVector, but that's maybe a more complicated story. It would be supporting GeoVectors' values here. It's not totally clear what that would mean, maybe. But then, but separately, I mean, given that it seems like, okay, it's reasonable to sort of do these component-wise Craiging, is there a particular reason not to support, a vector inside the value field in spatial predict, right? So you could just make 1 call, and maybe internally it makes it into 3 calls. But do you understand what I'm saying?
Right, and then return a vector valued function.
But
yeah,
that's the idea.
Just a second.
Sorry.
Some bug. Go ahead. What were you saying?
Well, I mean, I didn't hear really what the response was. Yeah,
I think it could. It just doesn't right now.
Okay.
That would then return a vector valued function. Although, yeah, there's some trickiness. Yeah. Think about that a little bit. The question is, how different are the components? How dramatically different are they in their spatial dependence?
Right, and the question is, do you have a cross-component dependence? Because right now,
but it wouldn't model that. Okay,
right?
It wouldn't model that. That's out of scope. That would be a different project.
So that's what I'm just saying, that it's doing component-wise, and so you don't look this as a
no, but it would still be a service to the user to automate that. Okay, just. So what Christopher and Stephen sort of points out is like, if someone has vector data, why should I have to split it and do it myself twice? Why don't we do it?
Right. Yeah, that's
okay. Fine. So then the values here could be vectors.
Yes.
And then although it is done component wise for now,
it can be any arrays. Then might as well be any array.
Right.
While we're adding things, it could also be an association, maybe.
Yes, that's true. Yeah, that's true. If it's got numerical values, why not? Okay, so let's
how do you call yeah?
where do you want to put association? I'm sorry, I'm confused.
I don't.
here.
Yeah, it's just.
Well, I mean, I'm just saying. I mean,
it's a question.
these are sort of convenience things, but like for the values there, right?
But I don't know,
you know,
what would you get from the output association at each point?
Yes.
Yeah, you'd get an association.
Yes.
I mean, just in the same sense that, it's just, you're just naming the indices of the vector you're putting in.
Yeah. I guess not. I guess that could work too.
Richard on our live stream is talking about co-Kriging, which I don't know what it is, but do you guys know about that? What is that? Multivariate variant, apparently, of the ordinary Kriging operation.
Yes, it's when it's something that we don't support yet or intend to. It's essentially exploiting possible having spatial dependence between the different values in the vector that we're just
right. Okay, so this is the difference between the component-wise and some kind of covariance.
Yes.
Between those. Okay, fine. So there's something we're not dealing with yet. Okay, let's go back to this main design.
Maybe, sorry, just as a quick question though. I mean, if we did end up supporting that, I mean, maybe there could be a method option that specifies whether you're doing it component-wise or with the co-Kriging or covariate Kriging method, right? I mean, if we add the support for putting vectors in, it would be silly if then that makes it so we can't add the maybe more proper way of supporting vectors and Kriging.
Right, I agree. I mean, we should just change the method basically. If we can do it taking account of the fact that they genuinely are vectors. All right, let's go look at this thing. Okay, spatial gen model, spatial noise variance. Okay, so those don't sound like options to me. They sound like things you would get out. What's the analog in time series of those kinds of well, okay, look, we've basically got, if I'm not mistaken.
This is intended to be that you can use it without specifying anything.
No, I realize that.
Okay, then these are drill down capabilities when you do want to specify things.
I get it. I understand. I'm talking about their names only. That's all I'm talking about. But let's talk about the main name, Spatial Predict.
Okay.
Okay. So, in the world of spatial statistics, we've got So, okay, what should we call this? This is supposed to return a thing. What does time series forecast?
This is a different branch of spatial statistics. These are the two main branches. The previous one that we dealt with, and now this one. These are the two branches.
No, I got it. I mean, it's points and fields in some sense.
Yes.
Okay.
No, you got it right.
I had that a long time ago, Roger. I just got, we were confused with trees. Okay. Anyway. Okay. The question is, what on earth do we call this function? And it really shouldn't be called predict.
Spatial forecast.
That's horrible. That sounds like a weather forecast.
That's why that's why we chose this name.
So hold on. I understand, but I don't think it's the right name.
I mean, arguably, what it's doing is for the most part, it's interpolation.
I know, but they're objecting. Yeah.
No, I know. But also the function predict is also arguably doing interpolation with many of its methods or things that you could call interpolation. So I don't know. I mean, I think it's like, I think you could argue that the methods are probably very similar to predict, but it just that calling it predict maybe gives it a bit of a machine learning.
It does,
twist.
and we really don't want to do that. Predict is crystal ball-y, and this is much more interpolation-y.
No, I mean, it's the same damn predict theory. Same theory. Okay.
Look, we can't call it predict. That is a machine learning brand unless we expect we're going to use machine learning stuff. Okay, so that's a question.
Fine.
Is the future of this, is machine learning useful for this?
It might be in the future. Now.
Not really.
Yeah, not really right now. But.
Okay, what do other people think? I mean, you see, okay, so what are some other names we could imagine here? I mean, this is, Ethan is suggesting, okay, spatial value impute. Value.
That's horrible. That's horrible. And it isn't. It's also wrong. when you do the imputation of values, you do stochastic simulation. This is doing expectation, effectively. It's the other way around.
Okay. What are some other words here? Okay, again, what is this doing? It's taking a bunch of spatial values. I mean, I have to say the word I would use to describe this is interpolation. And it's trying to figure out for you what, what the value is.
But interpolation by definition requires you that the resulting function goes through the data points, right? So that would be a very, 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 very special case for this.
I know, I realize that.
Spatial value estimate instead of impute, which is a word that is a little bit more pretentious. Spatial value estimate. Even though it's verbose.
Better meaning. So wait a minute. This is, you can give, like predict, you could give an actual, you could give the sort of data and then you give a specific value to get a prediction, or you can get a prediction function out. Is that correct?
No, you get a prediction function out.
Okay, but that's not good enough, because what we do, look, all these functions have a particular form. They take data, and we can say for that data, if you just
we
give
can
it data,
add that, okay? We can add that. It's not particularly important. It's kind
I know
of
it's not particularly important, but
it's very, very inefficient.
I understand all of those things, but for consistency with our other functions, we should be doing that.
Yeah,
it's like nearest and so on does that. So, okay. So the thing is that the imperative term, spatial predict, right, is that imperative term essentially requires, for it to be meaningful, a form like this, as opposed to a noun form, which is what you would expect if you are just producing a thing that will then be applied to data. Am I making sense?
Okay, so you want to call it prediction instead of predict?
No. I'm saying if you say that it is so useless to have the single value thing here, right?
Yeah.
Then it is possible that we can have a name that is the noun form that returns the predictor function, or whatever it's called, right? That then we have a slightly different namespace. If we say predict, it's got to work like predict, where you give it the data and you say where you want it to predict for.
Okay.
Even though that isn't.
Do you have a suggestion for a noun form?
No, I don't. I'm just saying that it allows us a little bit more freedom in what we, I mean, you could call it spatial estimation.
Or spatial estimator or something.
Or spatial estimate. I mean, which you might read as spatial estimate, but spatial. Is that crazy? Is spatial estimate crazy for the function?
It's not totally crazy. Wouldn't seem super intuitive to me, but it's not totally crazy.
Okay. See, one point about predict that I also don't like is that predict is for the future, so to speak, in some sense. Whereas what this is, much more like the typical use of this will be much more like the typical use of interpolation. That is just filling in data. Whereas predict is usually, I've got these things and it's like, what's going to happen in the future? That's not what this is about.
Oh, it's just your intuition is not there yet for spatial stuff. For spatial stuff, you predict the stuff that you don't know.
Well, you could call it prediction, but look, a lot of the use of this will just be, I've got this field of things, I want to fill in the field.
Yeah.
Right? But that's different from predict. Predict is future. Predict, say in advance, right? Which is different from fill in, which is the interpolation kind of idea, stuff that's already there. I mean, just sort of fill in around stuff we already know.
Sure.
I think spatial estimate is not terrible. Let's see. Let's take a look at these other names. I mean, that would be my first choice here right now. Maybe we can do better.
Okay.
Okay. So then it becomes a spatial estimation function for the actual, or spatial estimator function probably. Is that right?
Estimator, I think.
Yeah. Okay. Spatial estimator function. Okay. Now, okay. So are these different? What is this? Is that an actual function there?
Yeah. So variogram is the thing that tracks the spatial dependence, and that's the core of this function, if you like. This explains the whole story there. And this one, this is a big complicated function.
And roughly what it's doing is what? It's taking,
roughly speaking, it gives,
gosh.
yeah, there's a whole modeled world. So what it's doing, it's fitting one of those models of how the variogram behaves.
Okay.
And that gets you a robust estimator, spatial estimator function of how things behave nearby. If we go a little slower, I can explain more along the way.
You know what? I think we're going to run out of time here. This looks like this is a quite complicated thing to understand.
It is. I mean, not really, but it takes more than 2 minutes.
Right. Okay. What is bin variogram?
Bin variogram is basically like a sample variogram. It's a way to compute sort of a kind of a rough version of it. Unfortunately, it doesn't result in a legal variogram, but it's still an important indicator of what your data is like, the spatial extent of dependence.
Okay. But so what's happening here?
So the bin variogram kind of used as an initial estimator that goes into this model fitter. Which I'm saying that snaps up the quality of the underlying variogram model. So it becomes a legal variogram, and that can actually be used in that spatial prediction function, this predictor function.
What does model variogram return?
It returns a variogram function.
Which means what?
It's a function that can be evaluated at different points. And this is, think of this as, what do you call it when you have, I'm sorry.
Spatial estimator.
It's like a kernel function of sorts.
Yeah.
It like encodes the dependence.
But see, this doesn't look different in different directions. So it's what do you call it when it's the same way in every direction?
Isotropic.
Isotropic. So this is an isotropic model. So this is the radial dependence.
And how does that relate to all those radial functions for spatial point data? Or what are those called? The endpoint correlation. What is it called?
Per correlation, but that's different. So the per correlation is, that relates to the probability of finding points within a certain distance. And here you're looking at the values. So basically what, for example, the bin variogram does, it bins per distance. So you're looking at all the points which are distance given by this bin. So say whatever 10 plus minus epsilon meters or something like that. And then you look at the values at these points and you compute the covariance between the points to see, you're looking at the differences between the values.
Variogram and covariance is roughly this spatial covariance is roughly the same thing. They're sort of one minus the other.
Right, they are related. And the idea is that if you have these models, it shows you how fast the spatial dependence wanes off in what shape. So that when you move away from, when you increase the distance between the points, and that's what the model variogram function is. It models the dependence, the variation really between the points. So you see that the variogram function increases with distance because it measures the variation between the points. So the farther you go, the bigger the variation, and in usual, data field, it's gonna be the sample variance of your points of your data.
But so so just to understand, so the 2-point correlation function, were I to have a field of points, so to speak, that was just a grid, right? Then the pair correlation function, I see, that's just the presence of those points, independent of value. This is looking at the correlation of values
Yes.
between neighboring points.
Right.
Yes.
And also, as you keep in mind that you can have this underlying locations, they can be controlled. And while we're looking at the per correlation G and all the statistics there,
I know,
all
it's
these
just
points are
wherever the
random.
points are.
Yeah.
Yep.
Yeah.
Okay, but so my question here is, and then we should wrap for now, and we should have another one of these.
Okay.
My question here is, this concept of a correlation function in a scalar field seems like a more general concept than this. I mean, I've never heard of well, I have. I've heard of it. I didn't know what it was, this variogram idea. But the concept of a correlation function in a scalar field, I mean, at least in the physics world, there are plenty of places where that appears.
Yeah. Covariance function, correlation function, etc.
Right. So my question is, in terms of naming, if we say variogram, that's spatial statistics land.
Yes.
And the question is this, I mean, is the core operation here really a spatial statistics land thing, or is it something more basic about a scalar field, about a sampled scalar field, basically?
I mean, when we first started, I really didn't want to introduce, I really wanted to have covariance function, a spatial covariance function. The problem is that this one, the covariance function can't quite represent everything the variogram can represent. So that's why the spatial statistics folks landed here. Now,
although sometimes we have functions which are named for their primary, their primary conceptual thing, and then we have an extension.
Yeah,
so to speak. I mean, I don't think that's crazy. I think it's better to have a function which is named for what its primary conceptual idea with an extension than to have a function that is named for some bizarre extended form that is not really related to the
no, I mean, but it isn't a covariance function here. It's as I said, they're related, but it's not the same.
This is a measure of variation, right? So hence the variogram, because it's a measure of variation.
Well, maybe we should also then, maybe the point is that we also should have the covariance function.
Not now.
Live stream is asking about, can we, okay, this would be a good exercise. Okay, that's, what that is, right? That is projected. I don't know what that projection is. What is that projection? That's a projection of the sky, obviously.
Mm-hmm. That's small y there. Astronomers use small y there.
Okay. And which is something presumably in our astro, I mean, how would we take in that data and do anything with it?
Well, it's the same situation as in Geo. We have the position containers, but not the field containers yet.
Okay, fine. But then, for example, your spatial statistics stuff should allow one to get, I mean, that should allow one to do computations on this data. Is that a true statement?
Yeah. But we need sort of, the question is, what are the positions? So they're going to be astro position then, presumably, the future astro position. So then it needs a small extension to work with those. Right.
But then this correlation function thing, this is, I mean, people try to compute correlation functions here because they might actually be, the correlations of quantum fields from long ago, so to speak. And it should be the case, if I'm not mistaken, and maybe Jose can unscramble this for a second. I mean, it should be the case that correlation function and the correlation function you're talking about here with your variograms are essentially the same thing.
I think so. I mean, they support already geo position, so this would be just
No, I understand, but the point I'm making, Jose, is that the correlation function, as in expected value of field at x and field at x plus delta, right? That's the notion of a correlation function, and what is the relationship of the that averaged over that the expectation value of a of x plus delta, right? And I think that is similar to what you're doing with this variogram. Am I mistaken or not?
You're not mistaken.
Okay.
Yeah, it's
similar.
Yeah, I mean the correlation is a function of variogram and the variance if the field is stationary, will be stationary. If it doesn't have.
So I would strongly argue that it's worth having a function, even if you have the variogram thing. It's worth having a function called spatial correlation or some such other name that just gives you that correlation function. I mean, I would have thought, okay, so in that world, in the physics world, the endpoint correlation function is of interest. That is, the correlation function with a of x plus delta times a of x plus delta prime. That's the 3-point correlation function. Does that have an analog in variograms?
No.
No.
Okay. But I mean, that's another thing that is interesting to compute. Okay, we should pick this up in another meeting. All right, I need to go. Good stuff.
We'll schedule one more of this.
Yes,
this is a lot of stuff, but one more time, and I'm sure that it will feel much more.
Yeah. That's fine. I mean, we'll nail this in another hour.
Yeah.
Sounds good. Okay.
Sounds good.
Talk to you